Hi, this is Tom, and in today's lesson, we're going to look at patterns of the parabola. I have two examples. One is a simpler example that's more illustrative so that we can better see, and then the second example will be a more complicated one so we can actually practice how all the pieces fit. So what we're going to do is we're going to take a look at the parabola y equals x squared minus 4x plus 3. And what we're going to do is we're going to find the vertex, axis of symmetry, intercepts, and graph. Oops. And graph. All right. So in order to find the vertex, we complete the square. So let's begin there. So step one is vertex. Let's do, actually I don't even need the one. Let's just write vertex. Here we go. I'll bring the problem down here as y equals x squared minus 4x plus 3. Remember our first step is we bring the constant term to the left-hand side to get it out of the way for a bit. So now I have negative 3 plus y equals x squared minus 4x. And then we notice that we have a negative 4, and we take half of that, and we get negative 2, or then we have to square it. That's the first thing we're going to need. So we square our negative 2 to get a positive 4. And then what we do, and I'm going to just do this time in one step, is I'm going to add my 4 to the right-hand side, and I'm going to add my 4 to the left-hand side as well. And so now we can clean up what we've got. On the left-hand side, I have 4 minus 3. I can write that as 1 plus y equals, and we know that the result of adding that 4 created the perfect square, and that's when we use this first little piece. So I write this as x minus 2 quantity squared. My next step is I bring the 1 back to the right-hand side of the equation. So I have y equals x minus 2 squared minus 1. And now we can read the vertex right from standard form. And let's just remember that's what this is called. This is called the standard form, or standard form of a parabola. And so our vertex is the point, positive 2, remember we changed the sign on the number in the parentheses, comma, negative 1. There we go. That's the first thing that we needed to do. And now, the axis of symmetry, and I'll write that here, I'll just put axis of, how about we'll write it out. I was going to abbreviate. Axis of symmetry is, it's just the x value. And so to make, instead of getting a single point, it's the vertical line that passes through x equals 2 for all possible x's. Or for all possible y's, I'm sorry. There. Now, the next thing we asked for are the intercepts. So let's bring this up here a bit. And our intercepts, well, the first one we want is if we find the y-intercept. The y-intercept's a great one because you just use y equals 0 squared minus 4 times 0. And then our last number was a plus 3. Plus 3. And so my y-intercept is at 3, but remember it's really a point. It's the point 0, 3. Now I'm going to So this is my y-intercept, and I'll make that note here. So my x-intercept occurs when x is 0. And I'm going to use the standard form, and you'll see that it goes much faster if we do. So what I'm going to do is I'm going to write this as 0 equals x minus 2 squared, what do we have, minus 1. So I'm going to solve this. So now I'm going to add 1 to both sides. So now I have 1 equals x minus 2 squared. I take the square root of both sides, so I have a plus or minus. The square root of 1 equals the square root of x minus 2 squared. So now I have plus or minus 1 equals x minus 2. Add 2 to both sides. And now I have 2 plus or minus 1 equals x. So now I have x-intercepts. We can write those. Our x-intercepts are at, well, this x-intercepts at, one of them is 2 plus 1, that's 3, 0. And our other one comes from 2 minus 1, that's 1, 0. Okay, got those. Then the next thing that it asks us to do, let's look back up at the top, is to graph this. So now let's graph our parabola. Okay, so I'm going to graph this parabola. And I have, I'm going to remember all my information, but I'm going to go to my paper and let's pick up some graph paper because they really come out better. So here's my graph paper, and I'm going to just put this graph right here in the middle, and don't really need that zoom feature. And I'm going to give myself some space on this one, and you'll see why. So we're going to annotate it a bit. There's some things we need to see. So let's make our graph in red, and then we'll do our annotations in another color. Now, if we looked back, our vertex occurred when x was 2 and y was -1. So x was 2 and y is -1. That's going to be this point right there. Then we had x-intercepts of 3, 0, and 1, 0. Well, here's 1, 0. Here's 3, 0. And then we had a y-intercept. On y-intercept, we look up here. Let's go back. 0, 3. So 0, 3 is going to be right there. Now, I already have a pretty good feel. Also, our axis of symmetry, let's put that in here. Our axis of symmetry is the vertical line x equals 2. So remember, that means that if you know one side of the parabola, you immediately know the other side. So let's check this. Notice that, let's see, we've already got the left half, a good bit of our left half, so let's put some more down on the left. So let's try our next value to the left, and we'll make a table. So let's try -1. So if I try this, I have y equals -1 squared minus 4 times -1 plus 3. That's going to be 1. Plus 4 is 5. Plus 3, that's going to give me 8. So my next point that I would graph is -1, that's over here, but then I go all the way up to 8. So I go 4, 5, 6, 7, 8. Pretty high up there. And let's try -2. Let's see what happens there. So now at -2, this will probably be our last one. Y equals -2 squared minus 4 times -2 plus 3. So that's going to be 4 plus 8, that's 12, plus 3 more, that's going to give me 15. So, wow. Now let's graph the point, -2, 15. That's a big one. So we have 8, so I'm going to go over, here's -2, here's 8, 9, 10, 11, 12, 13, 14, 15. I have to admit, that was luck that I made it just the right size graph. But when you have it, you got to enjoy it. So now from that, we can make the other side. So let's go back down here. In this point, it goes in 2 units, so we go out 2 units. Then our next point to the left goes in 1, 2, 3 units, so it needs to go out 1, 2, 3 units. And then the next one's going to come in 1, 2, 3, 4 units in, so I go 1, 2, 3, 4 units out. And that's using the property, the symmetry of a parabola. And now we can draw our picture. So I'm going to draw my picture here. This is a pretty big parabola to draw. I like this. There. That's our parabola. Now, let's take a look at a few very clever pieces that we've been kind of keeping in the background. Do you remember when we solved the quadratic equation using the quadratic formula? In the quadratic formula, we said it was x equals -b plus or minus the square root of b squared minus 4ac over 2a. But before we even got there, when we derived this, we said you can also look at it as -b over 2a plus or minus the square root of b squared minus 4ac over 2a. So what is this about? Well, it's actually about two things. Let's actually use, we're going to plug in our values, and I want to show you what comes out. So remember our parabola, we had a as 1, we had b as -4, and we have c as +3. So I'm going to do this kind of quick, but let's just watch what happens. So I'm going to use the second version I'm going to use this version here of the quadratic formula. And if I do, I have -b, that's going to be -4 over 2 times a. Well, a is 1, so that's just 2, plus or minus, and I have the square root of b squared. Well, if we square -4, we have a 16, minus 4 times 1 times 3 over 2 times a. Well, that's 2. Now, here's the interesting part. -4 divided by 2 is, oh, whoops. This should be a positive, because remember, it's minus b, so there we go. So this should be a 2 plus or minus. Now notice that we have 4 in the square root sign. We have 4 times 1, that's 4, times 3, that's 12. 16 minus 12 is 4. So the square root of 4 is 2. So this is really plus or minus 2 over 2, but that's just 1. Whoa! Let's take a look. That, if you look in the upper left corner of our screen, we already were there. So what's so important about that? Well, here it is. Here is the axis of symmetry. This is your x equals 2. So you know your vertex lies at the point that comes from right here. I'm going to use this in another color. From -b over 2a. Actually, that red is not a very good highlighter color. Let's use the light green. So -b over 2a, that is how you find the x value of the vertex. You don't even have to complete the square if you really don't want to. But look at what the plus or minus 1 is. here, so if we look at our parabola, here's where x equals 2. It's our line of symmetry. And notice that if I go plus 1, I end up at my first x-intercept, or one of my x-intercepts. And if I take from there minus 1, I end at my other x-intercept. Okay, now there's one more pattern to see here. And then we'll stop, and the next example will be another problem. Watch this. And I'll do this in another color. I'm going to need a pen to keep track of this. If I start at the vertex, if I know one side of the parabola, then I know both sides of the parabola. But look at what happens. I start at the vertex and I go over 1, up 1 unit. And then I go from the next point, I went over 1, up 1, 2, 3 units. And then from that point, if I go over 1, and I go up 1, 2, 3, 4, 5 units, I'm at the next. So I'm going to record this. It's always moving over 1, but our first one was 1, then a 3, then a 5. What do you think the next one might be? Well, let's see. I think those are odd numbers. I bet the next one is 7, but let's check. I go over 1, and then I move up 1, 2, 3, 4, 5, 6, 7. And in fact, that's the pattern. Once you know the vertex, you know the pattern of the parabola. And this is a specific one. And in this, our picture here, the A value is 1. And the general pattern is you go over 1 times A, then you go over 1 up 3 times A, then 5 times A, 7 times A, and if we had more space, we could even go over 1 up 9 times A. I guess we do, but we'd be all over our writing, but just to show you, we could go over 1, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would be the next point by moving over 9 times A. And that is the pattern of the parabola. Thanks for watching.